in the dependent variable, which is in the, now this is the market value, okay, which is explained by what? By how many? The explanatory power, okay, is by square feet and house age. It means that this house feet and how big is the house feet, square feet lah, means that how big is the house and also the house age. The explanatory power, okay, on market value of a house is only 55.58%. Okay, only 55.58%. There are other variables. Okay, that not captured in the model. It means that there are other variables than square feet and house age that may influence the house market value. And these other variables stand for 44.42%. You use 100% to minus 55.58. So it means that if you add more variables inside, if you add x3, x4, x5, our R square will increase. If you're having x2, you have x3, x4, x5, so probably your R square will increase. You know, you get what I mean here? Yes. Okay. Now then we go to F test. Now we go to F test. Okay. F test, okay, it shows the overall, whether the overall regression model is a good fit for the data. Okay, so now here, what is our F value? Our F value is 24.395. Okay, our P value here, how is our P value? You must be careful. It is 1.3443 E negative 0.7. What is mean by E negative 0.7? It means that we're having 0.7. 1, 2, 3, 4, 5, 6, 7. 1, 3, 4. So it means that here we have 0.7 here. So 1, 2, 3, 4, 5, 6, 7. 1, 3, 4. So it means that here, so it is less than 0.05. If it is less than 0.05, it shows that what? It shows that square feet, our independent variable, square feet, and house age, okay, are statistically significant, predict the market price, the market value. And it shows that this regression model is good fit of the data. Then we go to our equation. Okay, then we go to our equation. So our equations, then we look at the coefficient. So the coefficient for square feet is 40.911. For house H is negative 825.161. Okay, we don't need to put in the error term. So intercept is 47331.382. Okay, so the intercept. Okay, so this is our multiple linear regression. Okay.
Okay, doctor.
Okay, now, so can we proceed?
Yes.
Okay. Now, so this is what we have here. Then how are we going to do the interpretation? How are we going to do the interpretation? Now, the positive signs here, the positive sign of SF, it shows that the square feet has a positive relationship with market value of house. Okay, the negative relationships here shows that, okay, house H has a negative relationship with market value. Okay, now then this is the first thing that we need to interpret the relationship, whether it's positive or negative. Second, whether it is significant or not significant. It means that is it significant? Is it it really can significantly explain the market value? We look at the p value. Okay, we look at the for house H 0.182. The p value is greater than 0.05. While for square feet, it is how many zeros do we have? 7 0. 0.000000365. Okay, so it means that square feet has a significant relationship, but not for house H. You get what I mean here? So we mentioned that square feet is statistically positive significant related with market value. Or you may put, if you don't like, you can put as a statistical significantly positive relationship. Okay, with this is how you construct your sentence lah. Okay. While for house H, okay, house H, here I put it in the short form lah, market value. Since okay. So usage is statistically insignificant, negative, insignificant. It is insignificant. Related with, okay, are they related? They are positive, have a positive relationship, or they have a but negative, but the negative is not significant. So if insignificance, normally we will not discuss more on that. What we want to focus on the explanations is which is positively. Statistically, we have a significant relationship. If it is insignificant, we will not discuss much on that because it is insignificant. What we want to discuss more is on the significant aspect. So since is SF is significant, so now, so we discuss detail about SF. So what it means that 1, so the value, the coefficient is 404.91. It means that 1 shows that 1 what do you call that? What, how? One square feet, okay, will cost because they are significant, okay, the market value to increase by how much? 404. Okay. Correct, class?
Yes.
So one extra lah means that 1 extra square feet will be better. Okay. Means that every increase in every square feet, it will cause the market price to increase by 404. 404? No, not 404. 40.9. Class, I do it wrongly. Also, no one mentioned. You're right. 40.91 kan? 40.91. No one mentioned about that. Okay. With 40 ringgit. Okay. So this is the interpretations, okay, that we're going to look at. So now, after that, we go to correlation. Okay, we go to correlation. Now, just now I mentioned about multi-correlationality. Okay, so multi-correlationality can be detected using correlation methods. Okay, correlation it measures the direction. Correlation, there's nothing about correlation. Huh? Correlation is just to measure the directions of the linear relationship between the two variables. So, and the correlation coefficient is range from -1 to +1. So it means that it just tells you, okay, whether the two variables, their relationship is negative or positive. It will not tell you whether their relationship is significant or insignificant. Okay, so if it's positive value, indicates a positive correlation between the two variables. Negative values indicates a negative correlation between the two variables. 0 indicates no correlation between the two variables. It's no correlation means that no relationship, so no point. No point you go and evaluate them, okay? Now, so this correlation, besides telling us the relationship between two variables, okay, we can also detect multicollinearity, okay? So in detecting multicollinearity, one way, there are two ways. One is using correlation matrix. The other one is using VIF, which is this VIF refers to variance inflation factor. Not in the syllabus here. When you get econometrics, okay, your lecturer will mention about that. Now, so if the correlation value above 0.8, follow the rule of thumb, that is multicollinearity problem. Okay, so we look at this example. So we go and do our collinearity. So you go to data analysis, correlation. Okay, choose correlation. Then the input range, we include all. Label in first row. Okay, now, so this is the correlation. This is the correlation. So you can, is it positive? Why are we getting negative here? Market value. Something wrong, class. Something wrong. Market values. Why we have, it is impossible. Just let it be. Okay, now. Here, it tells us, but I'm quite curious about the data set. I think something wrong about the data set. Impossible again. Let me try again. Hold on, class. Let me try again. Impossible. Because normally it will be the same. Market value. So we have been all. Okay. Okay, now. So it tells us the relationship. So you can look at the market price and house age. This is why I'm also quite curious about the results, why we having negative here, but it shows us the positive. So house age and market value, it should have a positive, but now we getting negative. Okay, never mind. So square feet, positive, have a positive with house age. Okay, so market value have positive with square feet. So how to detect multicollinearity? Whether the value is greater than 0.8. But now our value less than 0.8. So this is less than 0.8. This also less, all are less than 0.8. One is less than 0.8. It means that there's no multicollinearity. You get what I mean here, class?
Yes, doctor.
So this is one way, but I hardly use multi-column. Normally, I still prefer using VIF. Excel cannot do that, but when in your econometrics, later on when we go to SPSS, when we go to and also when your e-views can do that, but Excel cannot do that. Okay. Is it okay, class?
Yes.
Okay, now we're using
Yes.
SPSS. Okay, we're using SPSS. We use the same data, okay, but we go and apply in SPSS.